Hey everyone, so we learned about least common multiples and common denominators today in class. We're going to use that to learn what we're doing today in this video. We're looking at adding fractions. Some of this should be a review. Alright, remember, we cannot add fractions unless all of our fractions have the same denominator. That's why we did common denominators today in class. Common denominator. There are 3 types of addition problems you will see. They're grouped into 3 different categories throughout this lesson, so it should break it down really easily. When our fractions have common denominators, we can add the numerator and keep the denominator the same. If you do not simplify your final answer, you're not done yet because your answer will not be correct. So everybody needs to make sure they're always simplifying their answer. So we know it says common denominator examples, so we know they're going to have the same denominator, but just to make sure, are our denominators the same here? Yes, so I can keep my denominator and I can add my numerator. 2 plus 1 is 3. Can I simplify this? No, you can't. So my answer is 3/5. Let's look at this one. You try it on your own and then play it again and we'll check it together. So, the first thing you should ask yourself is, are my denominators the same? Your answer would be yes. So when your denominators are the same, we just keep our denominator and we add our numerator. Add your numerator. 52 plus 3 is 55. So I need to see, can I simplify this? My answer is yes. So 55 divided by 5. I know both of my numbers are divisible by 5 because they end in a 5 or a 0. 55 divided by 5 is 11. 100 divided by 5 is 20. So my answer is 11/20. I know that's my final answer because I cannot simplify it anymore. Next, we're going to look at uncommon denominators. That's when our denominators do not look the same. A common denominator is the same number that both denominators will go into. If needed, list the multiples of each until you get the one that is the same. So, if we were looking at 4 and 8, we would list our multiples. 4, 8, 12, 16, 8, 16, 24, and so on, 32. Alright, do I see a number in my 4s and my 8s that are the same? Well, I see an 8, an 8, a 16, and a 16. You always want to pick the lowest, so we would have picked 8 for our common denominator. If you don't understand that, rewind it, watch it again as many times as you need to. Do not forget, what you do to your denominator, you must do to your numerator. As always, if you do not simplify your final answer, you're not done yet because your answer is not correct yet. You will get the correct answer, but it's not correct yet. So, we know we're dealing with uncommon denominators, so we know our denominators will not be the same, but we got to ask ourselves, is 5 the same as 10? No. So if you need to list out your multiples, do that. If you already know it, you can write it. But our multiples of 5, 10, 15, 20, our multiples of 10, 10, 20, 30, 40. Do I see the same numbers? Well, I see a 10, and I see a 20, and if I kept going, I would see more numbers, but you always want to pick the lowest. So we're going to keep the common denominator as 10. Well, how did I get from 5 to 10? I multiplied 5 by 2. But what you do to your denominator, you have to do to your numerator. So I multiply 3 times 2. Alright, so 3 times 2 would give me, 6, and 5 times 2 would give me 10, but that's not my final answer because I forgot about 3 over 10, so I need to add 3 over 10. Now, are my denominators the same? I have a 10 here and a 10 here. The answer is yes. So I can keep my denominator the same, and I can add my numerators. 6 plus 3 is 9. Can I simplify this? If you said yes, you might want to think again. No. 9 over 10 is my final answer, or 9/10. Now let's look at this one. Y'all try it on your own and then play it again and see if you can get it right. So, are denominators the same? Should always be the first question you ask when you're adding fractions. Are they? No, they are not. Let's find our multiples for 9. We have 9, 18, 27, 36, and 45. Now, our multiples for 12 are 12, 24, 36. Uh-oh, I realized I just said 36 here and 36 here. Do I have anything less that's in common? Do I see a 12 or a 24 up here? No, I don't. So I know 36 will be my common denominator. How did I get from 9 to 36? Good, I multiplied by 4. And what you do to your denominator, you must do to your numerator. How did I get from 12 to 36? Good, I multiplied by 3. And what you do to your denominator, we must do to our numerator. 9 times 4 is 36. 4 times 4 is 16. I'm just rewriting my fraction. Always rewrite your fractions because it's going to be so much easier than having all this mess over here. 12 times 3 is 36. 5 times 3 is 15. Now, are my denominators the same? I have 36 here and 36 here. Yes, so now I can add my fractions. 16 plus 15 is 31. Can I simplify 31 over 36? No, I cannot. So 31, 36 are my answer, is my answer. Alright guys, we're almost there. Last examples. Mixed numbers and carrying. Whether you have a mixed number, that's remember where we have a whole number and a fraction, so like 3 and 1/2. Where either you have a proper number or proper fraction, that's like 1/2, or an improper, that's like 3/2. See our number's bigger on the top than the bottom, or the number is bigger in the numerator than the denominator. You always do the same steps, so you must change all your fractions so they all have common, that's an extra blank, common denominators. Then you add your fractions before anything else. We just looked at that. Remember, we just looked at how to add fractions with common denominators and uncommon denominators. So you always take care of your fractions first when we're dealing with mixed numbers. Then you add your whole numbers. Guys, make sure you, what do you think I'm going to say? Simplify. Always, always, always simplify. Then you need to check, is your answer reasonable? You need to see if your answer is proper or improper. Don't forget, proper has a smaller numerator than a denominator. Improper has a bigger numerator than it does a denominator. These are just examples. These are not the only proper or improper fractions you'll see. If it is improper, so if it has a bigger numerator than denominator, you need to change it to a proper fraction. We call this carrying. We're going to look at it right now. Alright, so our first step, if you look up, you'll see that your first step is always to check that all your fractions have common denominators. Well, do our fractions have common denominators? No. Do I know what 4 and 6 can go into? 4, 8, 12, 16, and then I have 6, 12, 18. Well, I have a 12 here and a 12 here. So you need to rewrite your fractions. So you have 3. And how did I get from 4 to 12? Well, I multiply by 3 because I have 1, 2, 12 is my third number. What you do to your denominator, you must do to your numerator. 3 times 3 is 9. Now, how did I get from 6 to 12? I multiplied by 2. You don't do anything to your whole numbers. You keep your whole numbers the same. So 6 times 2 is 12. 5 times 2 is 10. Now, do I have common denominators, 12 and 12? The answer is yes. So, if you look up, you'll see that number 2 says add your fractions before anything else. So our fractions, we keep our denominator the same. Just cover up these whole numbers. Don't even look at them. Just look at your fractions. We keep our denominator the same, so I kept it the same. I put 12. Then I add my numerators. 9 plus 10 is 19. Then, look at number 3. It says add your whole numbers. So, these are my whole numbers, right? Because you can have 3 whole dollars and you can have 5 whole dollars. 3 plus 5 is 8. Number 4 says to simplify. Well, can I simplify 19 over 12? No. But I need to check. Number 5 says check. I need to see if my answer is proper or improper. Is my number bigger in the numerator or is it bigger in the denominator? My number is bigger in the numerator, so it means it's an improper fraction. So if it's improper, I need to change it to proper. So, how do I change it? I ask myself, how many times does 12 go into 19? Well, it goes in once, so I have 1 12 over 12. 12 over 12 gives me a whole, so I can cross this out and change it to a 9. Because I'm changing my whole number. I'm adding 1 whole 12 twelfths to my 8. So I change it to a 9. And then if I subtracted this, what would I be left? If I took out 1 whole 12 over 12, well, this is like saying minus 12. So 19 minus 12 would be, good, 7 over 12. So my final answer is 9 and 7 over 12. I'm just taking out my improper. And if you don't understand that, you can simply just divide, right? We can put 19 in the house and we can put 12 into 19 and we'll get 1 and 7 twelfths. Can you simplify 7 twelfths? No, you can't. So this is your final answer. 9 and 7 twelfths. How about y'all try one on your own? Try this one on your own and then we'll see how you did. First question you should ask yourself, are your denominators the same? And your answer should have been no. So how can I get from 8 to a number and then 3 to a number? Well, you can list your multiples, or you know that 8 times 3 is going to give you 24, and 3 times 8 will give you 24. And what you do to your denominator, you must do to your numerator. So I'm going to write times 3, and over here I multiplied it by 8, so I'm going to multiply the 2 by 8. You always rewrite your fractions, and you keep your whole numbers the same. So 5, 3 times 3 is 9, 8 times 3 is 24, plus, keep your whole number, 2 times 8 is 16, 3 times 8 is 24. Our denominator is the same. The answer is yes, so now I can move to number 2. Add your fractions before anything else. Okay, so I'm adding my fractions. I keep my denominator the same when I add fractions. 9 plus 16 is 25. Then you add your whole numbers. 5 plus 7. Well, what's 5 plus 7? Good, it's 12. Then you see, you need to simplify. Can we simplify 25 over 24? No, we can't, but we need to check. Is it proper or is it improper? Hopefully you said it was improper because we have a bigger number in our numerator than our denominator. So I need to see how many 24s can I get out of my 25. Well, 24 goes into 25 just once. So I can cross this out and I can change that to 13 and I cross that out. And how many 24s did I take away? I just took away 1. So 25 minus 24 is 1. So your answer, because that looks like a big hot mess, we change to 13, because I'm taking my whole number. Then I take my fraction. And 1 over 24. We call this carrying. When we carry our whole and we add 1, we call it carrying. Carrying is confusing. So if you don't understand it, please stop, rewind, replay. I promise you it'll make sense. And if you have any questions, please type them in the Google Doc and press submit. That's your next slide. Scroll down right now, answer the questions, and press submit. It is your responsibility, not Mrs. Grenade's, not Miss Hitchcock's, not Miss Smith's. It's your responsibility to press submit. You got some extra questions, so please do it, and we will see y'all all tomorrow. Have a great night.